Hey guys, welcome back. If you guys saw my last video, I did cybersecurity, the last three videos. See those? Those are with supervised learning with machine learning, both classification and regression. Also, I'll get into some of my other videos. If you guys are interested in DNA, I've got classification with ethnic predictions. See my other video where I provide the data set as well. See some of my other videos for clustering, where we cluster DNA results. One yours, and then the others Korean and Estonian DNA, which I provide that too. Links to that as well. This you don't need a data set for. This you can use any DNA file, your own from Ancestry, or any DNA file from anybody, just random DNA, it doesn't matter. However, guys, I use my own, and we're going to be doing two things in this video, and I'm going to leave links to those videos as well. We're going to do class separation with PCA. Yes, you can use PCA for unsupervised learning as well. We're also going to do anomaly detection too. Let me skip to that. You guys see where I go through my own DNA and I splice, because I do two parts. And then you see where I detected some anomalies in my own DNA. We all have anomalies in our DNA. No big surprise. I mean, that's why everybody's got, some kind of health problem, whatever. It doesn't matter. Everybody's got some anomaly in their DNA. It's no big shock. So don't be shocked if you guys go through your DNA and you guys see some anomalies. Anyways, guys, let's get started. And guys, where I do ethnicity prediction, I was going to get into that. See my other video, which I'm going to leave a link to. And before we get started, I was going to let you know, speaking of my other video, where I did my old results and then they updated. Well, it updated again as well. It's just it's been a while. Last time, I used to have Russian as a previous ethnic result, and then it converted to Bulgarian and Romanian and Czech and Slovak. But anyways, guys, if you guys can upload your DNA results to Genome Link. They have Deep Ancestry that just came out. Not the European report, but Deep Ancestry, where it's got, and guys, this is not just for Europe, this is for the whole world, where they've got over 200. So they are more specific, guys. But I do have some disagreements with my results because I don't have that much French. And obviously Iberian is because some Irish have Iberian from Spanish sailors washing up on the shores of Ireland. Also, Central and Northern Italian is really British because some British have Italian because of the Roman Empire. I thought that was unusual. Bavarian didn't show up, but I got German, Dutch, and then Flemish, which is Belgian. And then, guys, my results, although, guys, as you know, this is machine learning. We're not going to see my other video for ethnicity classification. Yeah, because it converted into these. Remember, guys, they assign it to, based on their data set, whatever is the most relevant to the regions. And they all have different data sets. That's why all these companies have different data, different results, different amounts, not all the same regions, or they change. And it's just how it is. Like, I didn't get the Bavarian region this time. When that's where most of my German ancestry's from, is the Bavarian region that's German. Anyways, guys, enough about me and all that. Import these, read it, label encode it, because we got to turn them all into numbers. Why? Because look at your DNA file. This, if you fit that with the standard scaler, it wouldn't fit. Also, these alleles. Those are not numbers. So we got to turn them into numbers with the label encoder. Also, guys, be advised, in some of my other videos, you can inverse transform to decode them later. Let's say you made there's many examples of that, and I use that in my many other videos. I go into detail for decoding predictions or decoding the old data frame to see what you encoded it as a cross-reference, kinda. Anyways, guys, we're going to be using PCA for the class separation, fit transform, and we're going to see the correlation map. This is my DNA. You guys see? You guys see the correlation map? You guys see how I did that? PLT, matplotlib, the library for data visualization. You guys see? And then I made the little color bar, the fig color bar. Okay, and then PCA, none, because we're making this totally none, n components equals none, because we're making this totally unsupervised. Okay, and then we're going to make a little scatter plot. The grid is true. And then, guys, put whatever title you want in there. Okay. And then as you can see, guys, there's 4 components. There's a big gap between one and the other. You guys see the big drop? But anyways, the point is there's 4. We're going to fit transform dfx. Remember? We fitted it, and now we're going to transform it. Now we're going to make a data frame of it. Okay, now we're going to be using class separation. Now we're going to make a little scatter plot. As you know, you guys can change whatever title you want there. And then the first principal component on X and Y label. You guys see? We're doing class separation. Now we're going to make it into a little data frame. You guys see the gaps? We're going to describe it, and then there's how you get your statistics. Okay, and then just to look at the info. Now, guys, we're going to splice because we have to put it in half, remember? X train, X test, because we need a train and a test set. So we're going to splice. You guys saw, because I saw how many rows were in there. Okay. Fit transform X train, X index, fit transform X test, PD concat. Now we're going to use PCA, where what we're going to do is we're going to freeze it and we're going to inverse transform. As you can see, it caught pretty much a lot of it, right? It's pretty much on point. Because that's kind of what you do, is you inverse it, and then when you inverse it, you catch gaps, anomalies, differences, what it's supposed to be. Somewhat mimicking a time series. By the way, it's not quite apples and oranges. I mean, check out my time series page. Time series videos. Got plenty of them with real world data. Or you can use your own. And I show you how. Okay, get anomaly scores. Return the loss. You guys see what we're doing? Okay, scores equals get anomaly scores. DF restored. Sources plot. Okay. Def is anomaly. PCA data. Fit transform the data. Return the loss. Okay. Because, guys, the threshold is how we're going to detect an anomaly. And, guys, you guys see how I saw the gaps, right? You see those gaps right there? Well, you're going to splice and do a little detective work. You guys see? Look at all this. You guys see? So there is some anomalies. Not You guys see? 55. Oh, you guys see that big gap right there that goes deep? Anyways, guys, just so you know, you can apply this not just to DNA, but you guys can apply this to many other data sets. However, guys, let me show you something. If you guys have labeled data, what you guys can do is drop the class, drop the class, and then you guys can put that right here, DF, and then whatever class you dropped earlier, add it right there for the class separation. You guys see? You guys can also change the colors if you want. The alpha, too, if you want. Anyways, guys, I hope you learned from my video, and then you guys see the heat map. You guys should apply this to many other projects. This helps with non-technical people understanding the data as well. Just like in the real world, as a machine learning engineer, they might want to know how your model performs, but guess what? Guess what? They're non-technical, so use a confusion matrix. They understand. Don't worry. Okay, and then as you can see, we needed to label and code RSID because not completely numbers. Alleles 1 and 2 because they're letters. Okay, and then you guys see what we're doing, and then how we decided to put 4 there was because there's 4 in the component. You guys see? It's just like if we did clustering. See my other videos for that, for mol data and for DNA. But the thing is, we use the elbow method in k-means. DB-scan is usually not that good in my experience. Neither is hierarchical. Hierarchicals kind of shoot from the hips. Other types of clustering. Okay, okay, you guys see? You guys see how we froze, but they're not quite the same? They're close, but not quite. You guys see? Because there's some gaps. And then as you can see, there is some anomalies. And you guys can change the threshold too, you guys see? Like right here. Let's change this one. Probably going to be the same. Yeah, that's what I thought. This is just for fun. Anyways, guys, I hope you learned from my video. And guys, also check out some of my other videos for everything from MLOps to Azure deployments to Google Cloud. And by MLOps, I mean SageMaker pipelines and also just SageMaker models itself. I've got it all. Check out Streamlit Cloud, Render Cloud, both using Streamlit Framework, basic machine learning, convolutional neural networks, AI web apps with natural language processing, sentiment analysis web apps, reinforcement learning. I've got 13 videos. Check out my playlists. I got IBM Watson deployments too. There's so many other videos. There's 152 other videos. If you're here already, there's something else you need. I guarantee you guys. Okay. Now, I guarantee you guys need something else. Feel free to share my videos. Feel free to like if you liked it. Feel free to subscribe if you haven't already. And please share. Please check them out too. And also, guys, before I go, one last thing. Remember, I was going to tell you, every company, although Genome Link has gotten a lot better because they use academic data sets, a lot of the companies use self-reported ancestry. Not all. And guys, also, you guys can find other relatives on here as well, just like all the other DNA companies. If you take the test, you'd be surprised who you have as a fifth, fourth, or third cousin. Or it doesn't surprise you based on your tree. It all depends. Enough about me. Okay. I don't know. I just think the heat map is pretty interesting. Look at the color bar added too. And I already showed you guys. Yeah, you guys can change the title right there. You guys can change the colors. And check out my other videos. Anyways, guys, I hope you learned. Also, feel free to comment on it and comment what else you might want me to do. I'm starting to run out of videos. I'm not trying to be repetitive, but I'm, trying to. I'm running out of videos. If you guys could please suggest some ideas, that might help me. Thank you, guys. Bye.